Okay, this will be part 3 of our semester exam review, which is going to start at problem number 14. So in problem number 14, we have two different kinds of employees, a senior employee and a junior employee, and what we have to figure out is the hourly pay for the junior employee. So it says that a senior employee who works 18 hours earns $40.50 more than a junior employee who works 22 hours. So basically we have a difference of money here. So it says the senior employee earns $16 per hour. So we know how much they make an hour and we know how long they work. So we can find the total money that a senior employee makes is going to be 18 hours times $16 per hour, which is $288. Now we know that the junior employee makes this much less than the senior employee. So if I take the senior employee and I take out that difference, I'm going to get $247.50. And this is the total money that a junior employee would make if they worked 22 hours. So now I need to figure out how much his pay is for 1 hour. So I take the total money that he makes, divide that by the total hours he works, and I'm going to get an hourly rate of $11.25. For number 15, they want us to write an inequality that has the solution set that is shown in the graph. So first off, I have a horizontal line. I know that its slope is 0, and I know that its equation is y equals. So for an inequality, I can use some of that same information. I know I'm going to have a y, and because this is a dashed line and it's shaded below, I'm going to have a less than, and then I need this number right here, which is a -3. Because it's horizontal, I need a y. This is the y value that I need, and then the shading and the dashed line tell me that I'm using a less than symbol. Okay, problem number 16. Says if the graph of y equals 3x, if the graph of y equals 3x plus 8 is translated down 12 units, what equation would describe the new graph? So if I'm moving 12 units down, I'm moving the y-intercept. So all I have to do is take the y-intercept in there, subtract 12 units from it, and I get a new y-intercept of -4. So the equation would be y equals 3x minus 4. All I did was take this and go down the y-axis 12 units, and that left me at y being -4. For number 17, what inequality represents all the values of x for this inequality when y equals 16? So they've told us what y equals, so we are going to substitute that in and solve for x. So in this case, we need to simplify the right-hand side by applying the distributive property. I still need to simplify the right-hand side because these are like terms, so I'm going to go ahead and combine my like terms. Now I can start solving because I've finished all the simplification. We got to get rid of the 106. Then we get rid of the number in front of the x, so I'm going to divide by -6. So I stop and I change the inequality symbol because I'm dividing by a negative. Not because I'm dividing, but because I am dividing by a negative. So then I do 90 divided by -6 is a +15. But to graph this, if I needed to graph it, I really want the x on the other side. So if 15 is bigger than x, that means x is smaller than 15. So x has to be less than or equal to 15. And just for grins, we'll go ahead and graph this. You would put a closed circle because there's an equals component, and we want to go to the left because this is where things are less than 15. For problem number 18, we are looking at finding the domain and range. So domain is your x values, range are your y values. This is a continuous graph, so I'm going to put this stuff here so I can figure out what my lowest domain value is, what my highest domain value is, and whether I need an equal sign or not. So along the x-axis, I can go as far left as 0, because I've got a boundary right here, and over here I have a boundary that ends at 5. So I have a 0 here and a 5 here. Now, is it equal to 0? No, because it has an open circle. Is it equal to 5? Yes, it is, because it has a closed circle. So the domain moves left or right, and so it's like you have these walls as boundaries as you're moving left and right. The boundaries for the range moves up and down. So they share this point, and we have that one. So looking at the range, the lowest value I can go, I can't go below 0, but it is equal to 0 because of this point here. And I can go as high as positive 4, and it's equal because there's not a circle there. So this is also an equals. And is this a function? Yes, because it passes the vertical line test. Okay, so next is number 19. So several friends are working to make bracelets. Use a table of values to create a scatter plot, then draw the trend line and predict how many bracelets they could make after 20 minutes. I do not have a graph to be able to draw the trend line, but I can show you in the calculator how that would work. First off, we need to go to Stat, and we're going to Edit. And I need to clear out the information I had, so I push the clear button and enter, and that gets rid of all those entries in L2. Do the same thing with L1. Notice I didn't hit the delete key, I hit the clear key. Then I'll put all of these minutes in here. And then all the number of bracelets. Okay, so at this point, if I want to see a scatter plot of this, where I go is stat plot. So I'm going to do second y equals, and I'm going to turn this guy on, and then just hit graph. And there's all those points that we got for, let's go to y equals and clear that out. Okay, so these are all the points for my scatter plot, and that trend line is going to be right in there. So this looks like it has a positive correlation. So we're going to say, is there an association? Yes, and that is going to be a positive association. And is there causation? Does the number of minutes that you work affect the number of bracelets you make? Yes, it does. So they want us to figure out how many bracelets we would do in 20 minutes. So I'm going to go back to Stat. I've already edited and put in all of this information, so now I'm going to calculate that linear regression so that I can see what my equation might be. So that would be approximately 0.21x plus 0.29. I'm just going to go out to the tenths. And I'm going to go back to y equals and put that information in. The slope that I got of 0.21x plus 0.29 for a y-intercept. Let's see what the graph would look like. So there is that trend line that they've asked us to graph. And to figure out the number of bracelets, I'm going to go look at the table and just be scrolling down for this one, and we would get 4.49. So I would say they can't make a full bracelet, so this would be 4 bracelets that they would make in 20 minutes. Now back here at stat, when we calculated, I had not turned on the stat diagnostics, so I can't do the correlation coefficient. So let's turn that on now and recalculate. Go to mode, go to where it says stat diagnostics and turn it to on. Then we can go back to stat, calculate the linear regression again, and then it will tell me my R value. The R value for this data is 0.8903. And what type of correlation is this? It is a strong correlation, and because the number is positive, it's a strong positive correlation. So that is part 3 for your semester exam review. We'll come back and start with number 20 for part 4.